1.2, graph quadratic functions in Vertex or Intercept form. We just did a lab on the Vertex form. Transforming quadratics. And that lab was all about Vertex form. In the very first lab, we experimented with the A value and how the A value determines whether the function is opening up or down, how the A value makes the parabola wider or thinner. The width of the parabola has to do with A. In the lab, we experimented with what would happen with the H value and the K value. And so we see the parent function is y equals x squared. That's always at the origin. No shifts. The A value is 1. It's the parent function. Then we could see through the lab that we did that we translated H units horizontally on the x-axis. It's with the x number. Or we are translating horizontally H units. And then vertically K units for the Y value. So H is your X, K is the Y value. Notice that it says H. There's a negative in front of this. The negative sign is part of the equation. We need to cover that up, and we can see that we're using the H value, not negative H. The characteristics of the graph of y equals a times x minus h squared plus k, the vertex is hk. I am going to move over h units and then up k units for the vertex. We also see that the axis of symmetry, the AOS, is the h number. I have my vertex, then I have my AOS. Let's do an example. The first thing that you want to find is the vertex. It's called vertex form. That means the vertex is going to be very handy here. The vertex. The vertex is not at 2, but negative 2. Because it would look like x minus, there's the equation, but then there would be a double negative here. So the vertex is at negative 2, positive 5. So I go to negative 2, positive 5, negative 2, positive 5, and I put my vertex. If I have my vertex, I know the AOS, the axis of symmetry, has to go right down through there. The equation of a vertical line is x equals a number. So x equals negative 2. I need a point on either side so that, again, I can use my symmetry. And we know that the Y-intercept is the easiest value to calculate. So the Y-intercept I am letting x equals 0 to find the Y-intercept. And then we just simplify. 0 plus 2 is 2. 2 squared is 4. So I have negative 1/4 times 4 plus 5. Make my fraction. Multiplying comes before adding, so I would cross cancel my 4s. And I'm left with negative 1 over 1. So negative 1 plus 5. We see that when x is 0, we found that the Y-intercept was 4. I cannot just look at the 5 like we do in standard form when we see a constant and assume that it's going to be 5 for the Y-intercept. When it's in vertex form, you need to substitute in 0 and find out what that Y-intercept is, which is 4. So when x is 0, y is 4. And now I can use symmetry to get my final point. 2 on this side, so 2 units on the left, and sketch that parabola. The directions will say to label your axis of symmetry, your vertex, and we are done. Example 2, civil engineering. The Tacoma Narrows Bridge in Washington has 2 towers that each rise 307 feet above the roadway and are connected by suspended cables as shown. Each cable can be modeled by this function. Where x and y are measured in feet, what is the distance d between the 2 towers? Looking at our equation, it is in vertex form. I would say that the vertex is at 1427.
The axis of symmetry goes right down the middle.
So I know that this point is 1400 and y value is 27. This is the vertex. So that means that we're going over 1400 units on this side. That would also mean 1400 units on the other side as well. So we would say over here is 1400, this side is 1400, and so the distance between the 2 towers would be 2800 feet. The final form of quadratics that we are working with is called intercept form. We are looking at the intercepts. Where is it intercepting the x-axis? It's intercepting at P, and it's being intercepted at Q. Those are the intercepts. In 1.3 and 1.4, we will learn how to factor. For this lesson, they will give it to you in factored form. What are the characteristics of this type of graph in this form? We have our A value out front still.
And we know A is telling us about the width of the parabola.
This time we have P and Q, and P and Q are those intercepts. The axis of symmetry is halfway between those points. And so what you're going to do is you are going to add up P and Q and divide by 2 to find that halfway point. That is how you find the axis of symmetry. And again, the A value works the same. If it's greater than 0, it opens up. If it's less than 0, it is facing downwards towards the negative direction. Let's do an example. If this is called intercept form, then I should be finding the intercepts to start with. And that would be the x-intercepts. The x-intercepts are going to be at -3 and +1. Remember in the formula, there are subtracting signs here. That is why we are doing the opposite of what we see. The x-intercepts are at -3, 0 and 1, 0. You need to label your intercepts. 1 is already labeled for you. Now we just need that halfway mark for where the axis of symmetry will be. The axis of symmetry here is going to be x equals P plus Q divided by 2.
If our axis of symmetry is at -1, we know that the vertex will also be at -1. All we have to do is substitute in -1 to the function to find the y value of the vertex.
Therefore, -1, -8 is where we will find that vertex. Here I can see the U shape for the parabola. Our vertex is labeled, our intercepts are labeled, and our AOS. Final example, example 4. Football. The path of a place-kicked football can be modeled by the function y equals -0.026x times x minus 46, where x is the horizontal distance in yards, and the y corresponds to the height. How far is the football kicked? All right, so I'm going to start with the equation that they gave us. We have y equals -0.26 thousandths x. We have two x's here, and we need to solve for both of them. We can see that this one is going to be 46, but what about this one? We are going to learn in the next section that we take our factors. This is in factored form. We take our factors, and we set them equal to 0, and then we solve. Here, x is being multiplied by -0.26, so I'm going to divide by -0.26 to both sides of the equation. These would cancel, and I'm left with x equals 0 divided by any number is going to be 0. When I add 46 to both sides here, I get x equals 46. We can see that our x-intercepts are at 0 and 46. Here is 0, and this would be 46. That is where the parabola is intercepting the x-axis. All right, and because we're working in intercept form and a vertex, I'm just going to find the picture, and then I'll go back and answer the question. I know my vertex is here. So our AOS would be to add up 0 and 46 and divide by 2. Our AOS is at 23. So I know the x value here is at 23 for my vertex. All I need to do is find the y value. We will do f of 23. And we get 13.754. 13.75. So we know our vertex is at 13 3/4. All right, let's read the question again and see what they're asking us. How far is the football kicked? X is the horizontal distance. So from here to 46 yards. What is the football's maximum height? Well, here's my max. The maximum height is talking about the Y value, and that would be 13.75 yards. We will do the maximum and minimums on the graphing calculator when we come back, and we will also do the quick check 2 that has all 3 forms: standard form, vertex form, intercept form. We will do the second one when we come back. We will actually do the first and second one, but the second one is going in your notebook.